Okay, it's clear, so we enumerate here. So we have limit as x approaches infinity for the hyperbolic function of tangent is of x. We're just going to look at this, which becomes sine over cosine, which is equal to e to the x minus e to the negative x over 2, all over e to the x plus e to the negative x over 2. This is equal to e to the x minus e to the negative x, all over e to the x plus e to the negative x. We multiply e to the negative x from top and bottom, and we get 1. For part B, we're doing the limit as x approaches negative infinity for the hyperbolic function of tangent of x. And we get e to the x minus 1 over e to the x over e to the x plus 1 over e to the x. We're multiplying the top and bottom by e to the x. And we end up getting negative 1. For part C, we get the limit as x approaches infinity for the hyperbolic function of sine. We look at only the sine part, and this becomes equal to e to the x minus e to the negative x over 2, which is equal to e to the x minus 1 over e to the x over 2, which is equal to infinity minus 1 over infinity over 2, and we get infinity. For part D, we get the hyperbolic function of sine to be equal to e to the x over 2 minus e to the negative x over 2. And as the limit approaches negative infinity, this becomes equal to the limit as x approaches negative infinity for e to the x over 2 minus the limit as x approaches negative infinity for e to the negative x over 2. So we end up getting 1/2 times 0 minus negative 1/2 times infinity, which is equal to infinity. For part E, we're going to do the limit as x approaches infinity for the hyperbolic function of secant, which is equal to 2 over e to the x plus e to the negative x. And using the limit properties, we get 0. Since it becomes 2 over the limit as x approaches infinity for e to the x plus e to the negative x. For part F, the limit as x approaches infinity for the hyperbolic function of cotangent is equal to e to the x plus e to the negative x all over e to the x minus e to the negative x. We multiply the top and bottom by e to the negative x, which is equal to 1 plus the limit as x approaches infinity, e to the negative 2x, all over 1 minus the limit as x approaches infinity for e to the negative 2x, which is equal to 1. For part G, we have the limit as x approaches 0 positive for the hyperbolic function of cotangent. This is equal to the hyperbolic function of cosine over the hyperbolic function of sine. And this is equal to e to the x plus e to the negative x over 2 all over e to the x minus e to the negative x over 2, which is equal to infinity. For part H, we have the limit as x approaches negative 0 for cotangent, the hyperbolic function, and we get cosine over sine like we did in part G, and we get the same function, e to the x plus e to the negative x over 2 over e to the x minus e to the negative x over 2. And then we get e to the x plus e to the negative x all over e to the x minus e to the negative x times e to the x over e to the x, which is equal to negative infinity. For part I, we're also dealing with limits again, but this time for cosecant as x approaches negative infinity. This is 1 over sine, the hyperbolic function, which is equal to 2 over e to the x minus e to the negative x, which becomes equal to 0. For part J, I'll erase this part. We have the limit as x approaches infinity for sine over e to the x, which is equal to e to the x minus e to the negative x over 2e to the x, which becomes equal to 1 minus e to the negative 2x over 2, which is equal to 1/2.